So you take Laplace transform both sides. This one, Laplace transform of the second derivative is s squared. And then minus y prime of 0 minus sy0 plus, and then the Laplace transform of 4y prime, that's sy, but then there's also a minus y0 with the 4 multiplies as 4y0. Then plus 8 capital Ys. And on the other side, you get 20 cosine 4t, and if we use this formula, Laplace transform of cosine at is s over s squared plus a squared, with a being 4. The right side will be 20 times s over s squared plus 4 squared. And then you want to plug in the values. Y prime of 0 is -1, so -1 goes here. Y0 is 5. Y0 is 5. And then, since your goal is to solve for y of s, we're going to put these together. These, I'm going to factor the y of s, but the other ones, I'm going to move it to the other side. Now, -4 times 5 is -20. Negative of -1 is +1. 1 minus 20 is -19, which will become +19 if you move to the other side. -5s, if you move to the other side, is going to be +5s. So the result would be, once you do the Laplace transform, yeah, so you're going to get s squared plus 4s plus 8 capital Ys equals to 20s over s squared plus, let's just write 16. 4 squared is 16. Plus 5s plus 19. Okay, how many of you got correct until here? Okay, good. Now, let's divide by this. Okay, well, you could just divide as is. And it really doesn't have much difference if we combine this into a single fraction. But I think for a later presentation, it's easier to combine it first. So here's what I'm going to do. I'm going to multiply s squared plus 16, top and bottom, so I have common denominators. And then once you combine them, let's see, what was that? That's s squared times 5s gives you 5s cubed. And then 19s squared. And then you have 16 times 5s, which is 80s. And then plus 19 times 16 gives you 304. Oh, and then there's extra 20s that's added to here. So that's going to be 100s over s squared plus 16. And to this, I can divide by this in front. And as a result, I get y of s equal to 5s cubed plus 19s squared plus 100s plus 304 divided by s squared plus 16, but you also divide it by s squared plus 4s plus 8. Okay, now the next thing is, it's a matter of what to use for partial fraction expansion. And that part is mostly like the partial fraction expansion you learned in Calc 2, except there are a few differences. So here's what we used to have. We have to say that usually what you do is you put this s squared plus 16 that's something you can't factor, so you put, oh, by the way, don't write this yet because I'm going to change it. Okay? So don't write after the equal sign. Look what I'm doing. So first you're told to say, oh, AS plus B, and plus, you also have the other one, S squared plus 4S plus 8, and you're supposed to do CS plus D, right? Now that, if you just do it this way, then you're going to see that after finding A, B, C, and D, when you try to invert the Laplace transform, you'll have to do additional work. So we're going to be smart about it, and we will try to do the Laplace transform. We'll try to have the Laplace transform in mind, so we're going to change this slightly. So here's what I'm going to do. Instead of doing this way, first, instead of writing AS plus B, I'm going to write it as AS plus B over S squared plus 16, which is the same thing as AS plus B over S squared plus 16, right? And I like this because S over S squared plus 16 is this right side, so I know that that's going to give you the cosine AT, where A equals to 4. Don't you think, right? Mm-hmm. So I like that. But this one I don't like, because if I just have 1 over S squared plus 16, that's not what you have here. If this was sine 4t, you better have 4 over S squared plus 4 squared, right? So that's something I don't like. So instead of calling it this B, I'm just going to call this as 4b.
Multiply it by 4?
No, I'm not multiplying. What was B? What was B there before? I'm calling that as 4b, where like the old b is like b prime, and I'm calling it as 4b. So whatever value I had, so say that this was 5, this b will be 5 over 4. Yeah. Now, then you see that way, when you actually get the value of b, then it's that number times 4 over S squared plus 16, which will be the right side, so it's a lot easier for us. Do you see the reasoning?
Yes.
All good? All right.
No, not really.
Okay, all I'm saying is, look. I want this to be the same as that. I want this to be the same as that. Okay? Just keep that in mind. When you put something on top, you want one of them to be S over S squared plus 16, or 4 squared, like that. And the other one, I want this to match. Now I'm going to do the same thing for CS plus D. And again, I'm going to put two terms. And to just quickly say what I want to do is, first, complete the square. So to complete the square, you take half of 4, which is 2, put that inside. And then what goes here? What should I put here so that it matches with this?
4.
4, right? 2 squared plus 4 is 8. That's 4, but 4 is 2 squared, right? So I'm going to put like that. And again, the same idea. I put C times the first part, this S plus 2, and then D times the second one. Just match the second one with second one, first one with first one. And if you ask why do I want it that way? Well, that's because that's the way these formulas work. See, S minus A, same. B, same. Right? Therefore, if I manage to just find the value of C and D, then trying to invert this much is a piece of a cake. Yes?
So you think, for example, like our test next week, we should just like learn, I wouldn't say memorize, but learn that is the form we should
That's
use.
exactly what I'm trying to tell you. When you write down the expansion, partial fraction expansion, make sure that you're matching the first part, after doing the completing the squares, make sure that the first part is first part, second part is second part. That's the way to do the partial fraction expansion, which has the inverse Laplace transform in mind. Okay. If you don't, well, I've seen textbooks which they don't do this, but then after that you end up with more steps. It's a lot harder if you don't use this prescription. Okay, so hopefully that made sense. And now let's try to solve this. Well, you can, let's just delete everything here. Okay. So I'm going to multiply this much to here, 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 here. And you should keep track of which ones cancel. Let's see if you can follow the calculation. So you're going to get 5s cubed plus 19s squared plus 100s plus 304 equals, okay, first, as times what? S squared plus 4s plus 8. Good. Okay, next, 4b times what? S squared plus 4s plus 8 plus c times s plus 2, right? And then, oh no, I forgot something, right? What should I put here? S squared plus 16 plus d times 2 times s squared plus 16. And now I have to find A, B, C, D. Okay. It's a big amount of work. Now, what's even worse is that if you think of any good numbers to plug in, really, like s equal to 0 would delete this one, but it doesn't delete anything else. If you plug in s equal to -2, it deletes this one, but the other ones stay. So those don't really do much. Okay. So this is indeed something pretty tough, and there are many approaches at this point. So one thing you can do is you look at the highest order term, right? So as cubed, cs cubed, those are the only s cubed terms, and you have 5s cubed. So you can see that 5s cubed should equal to a plus c s cubed. So that's one nice equation. And then, although some of you might really hate this, you know, the best thing I see is to get rid of this s squared plus 16 by plugging in s equal to what?
4i.
4i, right? If you plug in 4i, that's going to delete this, right? Those will become 0 if you plug in 4i. And actually, it's not too bad. I mean, at first you might gasp, thinking that that's like nothing you've seen before. But it's not too bad because when you have two sides equal, their real parts should equal to each other and imaginary parts should equal to each other. So what ends up happening is just after one evaluation of 4i, you end up with the real part equaling each other, one equation, and an imaginary part equaling each other. So you have two equations immediately. Okay, and then once you have that, you're going to be able to find a and b, and this will give you c, and then at the end of the day, you can plug in 0 both sides to find out whatever that's remaining. Okay, so that's what we're trying to do. Right? So let's plug in 4i. 4 cubed is 64. And I cubed is -I, so this is going to be -320i. S squared is negative 16 times 19 is going to be negative 304, which cancels this one. And this will be 400i. And then you're going to get a times 4i times negative 16 plus 16i plus 8 plus 4b times negative 16 plus 16i plus 8 again. And then, as I said, these two cancel. 400 minus 320, that's 80i, equal to 8 minus 16 is negative 8. Negative 8 times 4 is negative 32ai. And then 16 times 4 is 64, but I times I is negative 1, so you get negative 64a. Same thing, negative 8 times 4b gives you negative 32b. And then 16 times 4 gives you 64bi. 64bi. And then combining the two, we see that 80i should equal to negative 32a plus 64b times I plus negative 64a minus 32b. Oh, I still need to save this because we'll forget what these are. Okay, so what do you see that? You see that this must equal to 80, right? So negative 32a plus 64b must equal to 80, which, by the way, is divisible by 16. So if I divide by 16, you get negative 2a plus 4b equals to 5. That's 1. And on the other hand, this has to equal to 0, right? So you have, and if you divide that by 32, if you divide by negative 32, so that gives you 2a plus b equals to 0. Oh, that's nice. So we can just add them together. 5b equals to 5, so b must be 1. Okay, and then when you plug in 1 back in, you get a equals to negative 1/2. And if a is negative 1/2, plug it in here, and you get c equals to 5 minus a, which is 5 minus negative 1/2. That's 11 over 2. So you're almost there. And now we can finish off by plugging in 0 both sides. Let's see what we get if you plug in 0 both sides. Or, yeah. So if I plug in 0 both sides, you get 304 equals to, if I plug in 0, that's gone. 32b and plus 32c plus 32d. Huh, interesting. All right. And then if I divide everything by 16, that's 19 equals to 2b plus 2c plus 2d. And if I plug in 1 and also 11 over 2 into b and c, you get 19 equals to 2 plus 11 plus 2d. So what's that? That's 13. 19 minus 13, that's 6. So d is 3. Okay? All right. So we're very close now. Here's the result of our calculation. The result of our calculation is that ys, the capital Ys, is as, where a is negative 1/2. Let me put it in front. Or let me just put negative 1/2 s. B is just 1. C is 11 over 2, and D is 3. Okay. From this, what's the function yt? Negative 1/2. What's this much? Cosine 4t, yes. This is plus. How about this one? Oh, that's a little tricky. What's the inverse inverse Laplace transform of this one?
Sine of 80 or sine of 4t?
Sine of 4t. Should I put a 4 in front or not? No, because it's including this 4, right? 4 over s squared plus 4 squared is the sine 4t. It is the Laplace transform of sine 4t, so it's just this. And then for this one, you should try to match it with this one right here, with a being what?
Negative 2e.
Negative 2. So you need to put plus 11 over 2 e to the negative 2t cosine 2t. And likewise, that one will be plus 3 e to the negative 2t sine 2t. And that's it.